Well, we have indeed learned how to calculate relative and absolute frequency. In this video, we will address how to calculate the arithmetic mean using data or by using relative and absolute frequency. To do this, we will take a close look at the following definition, which we will go through step by step. Alright, so we start with the data x to xn. Then we have the word sample with size n. Let's go through this briefly. First of all, I want to say something about what the word sample means. A sample means that it consists of data that is only a part of the population of objects that we are currently considering. This means that we do not have all the objects here, but only a subset. This is how we would say it in everyday language. When, for example, we look at the sample in the context of opinion poll. So we have our data from x to xn, and just to clarify, these are univariate data, which means that each data point contains exactly one number or characteristic. And whenever we do not specify it, we mean univariate data. And then the size n indicates that there are n data points. Then we have the values a to acusand, and we have the absolute frequencies h to hk. Perhaps a brief note about k. Of course, we can immediately consider why k is less than or equal to n. This is simply because, of course, each data point has a value, but two data points can have the same value, for example, 2001. So there may be fewer values than data points. And h refers to the absolute frequency of the value a, and f is the relative frequency of a, which is h divided by n. Well, now we are here. We can now define the arithmetic mean as the formula using. And in fact, you may have already done this when you calculated your grade averages. So what do you do then? You calculate the sum of all grades and divide it by the total number of grades that have been awarded, which is the scope. And you can see it here. You have the sum of 2001 of all your grades, and you divide that by the number of grades that have been given. And we oftentimes refer to the arithmetic mean as x bar. This means that you simply write an x and then a line over it, and it is pronounced like x. And the x refers, of course, to the data x to xn. And if you have grades now, you can make it a bit simpler by saying, I count how many times I got a 1, how many times a 2, 3, and so on. And then I multiply the number of times I got a 1 by 1, the number of times I got a 2 by 2, and so on. And the number is the absolute frequency. This means that the formula you then get is high times ai, which is the frequency times the value itself. And they do this for all values and then divide by n, so they obtain the second formula. And finally, they can take this n here and cross it out, and instead write it into this sum. Then you have here high divided by n, and there you know what it is. That would be the last formula. So the relative frequency times the value itself. And perhaps here again, to make it clear why we are primarily dealing with quantitative characteristics. Well, only quantitative characteristics can be added together. So you cannot add categories, like cats and dogs together. You can only add numbers together. Finally, let's do a short example. Imagine that 5 students achieved the following scores on a test. So, calculate the arithmetic mean, and it really is as simple as you think. You add 68, 72, 81, 90, 77, and then 90 plus 77. Then they divide by the number of values. So 1, 2, 3, 4, 5, and they divide by 5 to get the final result. And the others That was, so to speak, when they formed the sum of the she's. So if they now form the sum of the i's times hi, they would arrive at the same formula, because in this case, each value is indeed reached by only one data point. You can also take a look at an example where a value occurs more frequently, for instance. Well, that's it for now, and in the next video, we will look at how to determine another value that represents something like the middle or the average, namely the median.